Everybody, thanks for joining us. In this session, what I'd like to do is walk through what we consider 5 families of computer vision algorithms. Now, we've grouped these algorithms just to help you think about when you'd use particular algorithms versus others. There is a sea of algorithms to use, 3,000 plus, and this will hopefully just give you an overview of the different types of algorithm. So with that, I'll pass it over to Dara. So, hi Dara.
Hi Andrew.
So we have these families on the screen here that you've drawn, and you've given us some of your lovely pictures. So let's start from the top and talk about the thresholding family.
Yeah, so in no particular order, in this, lesson or whatever, I've decided to kind of group a lot of algorithms that are out there into 5 sort of families of algorithms. And probably the one to start with, as you say, is the thresholding algorithm, because it's amongst the most simplest of the algorithms. And it's still pretty powerful.
And useful.
Oh, and very useful. Oh,
great, well, let's dive in. So what's involved here in this algorithm?
So in the thresholding, what you're looking for is if you could get an image that was, if I go over here and draw kind of an idealized image to be threshold, that you could take maybe your little cup here.
So you've got your coffee cup and you're kind of...
And I'm just kind of drawing a very simplistic coffee cup here.
Okay.
If you've got an image where you've got a very, you've got a simple object, you've got a very simple background.
So there's a distinct boundary between the object
and that you're interested in, and the background that you're not interested in. And, if you can see a lot of really good gradients or edges or color differences around the border between those objects.
Okay.
And that's really good. You can even have... if you could have a job where you're segmenting coffee, you could do like that. You could have more than one of them, but they have to be very, very distinct and very, very clear.
So it's useful for reasonably simpler scenarios. I wouldn't say simplistic, but simpler scenarios. And also in this case, if you look at that cup you have here, if that was on a conveyor belt in my coffee mug factory, I'm controlling that background.
Absolutely.
A very straight background, and I've got these images, and I know what I'm looking for. And this is where threshold. And is it an expensive operation?
Oh, no. In terms of CPU, you can do that on a really tiny embedded microprocessor.
Great. So it's a great place to start.
And it's a great place to start. Just learn about
and the theory and what we learn here we'll carry on through.
We'll carry on through.
Wonderful. So let me try and clear us here. I'll just get rid of these. Okay, so now we're on to clustering, and here I believe you swam to the bottom of the ocean to take this picture.
Absolutely.
Lovely.
Absolutely. So I picked a picture of a starfish here, and this is an image that we're going to work through in the clustering lab. And, I picked this because we're going to use it in the lab, and in the lab we're going to learn a lot about clustering, so I needed a certain type of image for the lab.
So what are the characteristics here that make this a good candidate?
A good candidate, exactly. So what you get with clustering that maybe is like a sort of an extension over thresholding is if you had an image where you've got a couple of, maybe you're starting to get images that look a little bit like this, okay? You've got 2 or 3 objects now that you want to find in the image.
Yeah.
And, instead of just the one, and they're different. They're different kinds of objects. Maybe, if we just stick with the color, maybe is probably one of the easier ones to understand. If you've got, an object that's mostly green, if you've got an object over here that's totally distinct, it's mostly red, and a different object over here. That's when you can, clustering, I think, starts to come into its own.
So this is in your problem space, you're telling the algorithm you're using that, hey, could you cluster using a particular feature or property?
Yeah,
and
exactly.
Color would be a classic one. And do I know what I'm clustering at this point in these algorithms, or is that up to the person who's designed it?
That can be up to the person who designed it,
And you cover a lot of this in the course.
And then I cover a lot
K-means.
K-means is a kind of a one, and we get to understand a little bit more about the types of parameters we use, and and then that will lead on to that will link in later on to more smarter algorithms.
And as we head down, Dara, is this computationally much different than a thresholding algorithm?
It's computationally, it needs more juice than a simple thresholding algorithm, but you're still okay. You don't need a big GPU cloud server on the cloud.
So, and as our students will find out in our course, this is the kind of thing that libraries can help us with out of the box, right? OpenCV and others will.
There's a lot of libraries that we'll be using NumPy.
Fantastic. So I'll just do my job and try to clear our little screen here. So far, so good. So now another beautiful creation from Dara, namely of tomatoes, or tomatoes, depending on where you're from. So let's talk about region growing.
So region growing. So for this one, and I'm just going to use my little tomato images here, and I'm just going to try and highlight some of the key things that are in this image and why we're using a region growing algorithm. So what we're looking at here is, or what's the kind of takeaway from this when we start to think maybe region growing is particularly effective, is what we have here is we've got, if you look closely at the image, you'll see there's certain parts of the image where the objects are touching.
Yeah.
And, there's actually one or two places in the image where the objects overlap.
And that relates back to the picture you have here. They're very close, they're compacted in.
They're compacted in.
Okay,
yeah,
and what we're trying to do here is to find each object in the image. So
So what we're trying to do is find distinct objects in the image.
Great. So, Dara, let's move on to region growing and your wonderful tomatoes/tomatoes, depending on where you're from, and talk about this region growing set of algorithms.
So, I didn't put any particular order on them, but funnily enough, these three do seem to have a certain type of order.
Okay.
So, with the region growing algorithm here, and what I'm trying to do here is just illustrate some of the highlights of this image of tomatoes here, so that you can sort of see where these region growing algorithms come into play.
And I see you're doing that deliberately. You're deliberately trying to mimic the touching of the tomatoes.
Yeah, absolutely. What the key thing with this image, what it's got is these objects are all touching each other, and in some cases they're overlapping. And you can see, for instance, what you have here is two red objects. Effectively, what we're going to do is we're going to set up some centers here, one for each of these of our desired objects. We're probably going to set up another object out around here.
Yeah.
And what we're doing is going to feed those into an algorithm called the watershed algorithm.
Okay.
And without delving into the detail of how that algorithm works, just at this stage,
just in this overview,
just in this overview, we're going to see how that's going to grow out these original seeds back out until they start to kind of meet each other and clash with each other.
Got it. So you're starting from somewhere and you're asking the algorithm to go find the boundaries, go find where we hit off other. So the region growing speaks to that process.
That's exactly
fantastic. Great. Well, so that's number 3, region growing. And I'll just bear with me while I get rid of this again. Okay, edges and corners.
Yeah, so obviously in any image, edges are really important, and that's why I picked here this example of a glass.
Yeah.
In this one, I really wanted to highlight that, and if I draw it out here, you might be able to see a little bit better that what we have here is and I might just change the color here just to show. These edges, if you're image processing, to be able to get
clean edges.
These clean, straight edges here is fantastic, and that's a fantastic asset if you're trying to segment an image. So even though in this case you can see the background is relatively complex, because we're able to get these good strong edges, we can just take that glass
Okay.
right out of the scene. And we have a lab where we'll just take that glass just
Great,
just out of
fantastic.
that
So when I
scene.
look at this, though, I think clean edges, vertical, horizontal, they look really nice. Then I go back to our friend in the deep sea, the starfish, and I think it has lots of edges.
Absolutely.
Could we have used that here?
We could probably have tried to use the edges for the clustering for that starfish. That starfish got a lot of really good edges. It'd be interesting to try, and if there's somebody out there who's keen on this,
See what edges.
Yeah.
But the important thing is, I think, for the students is that there will be moments where you'll have to make these decisions and figure out for yourself, try stuff out.
Yeah.
That's why working in a Jupyter notebook and doing it fast and furious to figure out what works.
And a lot of what we're about here is showing that there's a lot of manual work in this classical algorithm. A lot of manual work, a lot of tuning and finding which approach is best, and figuring out, maybe I need to blur this image up a little bit and take it into clustering, and maybe I need to sharpen it up a bit and take it through an edge processing.
So what's really involved here behind the scenes, and I know we're only giving a very brief overview, is the idea of you have an image processing pipeline for cleaning up some of this stuff. There's a lot of handcrafting going on, and as we evolve, go through the whole course, some of this stuff will be taken care of us. We leave it up to the machine to help us figure out some of stuff. Fantastic.
Exactly. That's where we're going.
So that's edges and corners in terms of computational power and differences between any of these is still
usually pretty low.
Pretty low. Okay.
Yeah,
low and
usually
fast.
pretty low and fast. You're just
Fantastic.
once across the image.
So before we continue, I just want to again stress to our audience, to our students, that this is how we just viewed this set of algorithms, and but it's not hard and fast rules, and there's lots of algorithms behind here. We're just giving you examples of how these differ from a characteristics perspective. Let's move on to, finally, templates.
So templates, just to convey kind of how templates work. So I'm going to draw, a pretty sort of simplistic little shape here.
Okay.
And you might, recognize what that shape is.
That looks to me like a face.
Exactly.
Without a nose.
Without a nose, you're right. There you go. There's a nose on that face. Now, what we're going to do here is, if you can imagine, we're going to use this as a little tiny image.
Okay.
A very, very simple image. Okay. And now what we're going to do is we're going to search a much larger image which contains maybe all sorts of
objects and edges.
And, but in here is a sort of a set of edges that might somehow resemble the template.
Okay.
And then what we're going to do is essentially we take this template here and we put it over the other image and we perform some mathematical operations. We get a score, we keep that score, and then we start to move that image along, repeating the same process,
scanning with this template
across the image.
Okay.
And you can imagine once we've gone across once, we come down, and then we start to do scan again, and down and scan. Each time we're accumulating a score until eventually,
we do or don't
find what it is that we're looking for.
And there's a lot more to this in terms of scaling of images, and how do we scale these feature detectors versus the images themselves. And so we're just giving you a very brief overview.
Just a brief overview.
Okay, so that's templates.
Yeah.
Again, this is one of the kind of classical techniques in computer vision.
Yeah.
CPU based could work, but it gets more intensive now.
It tends to get more intensive, exactly, because what you've got to do is, you can imagine, as the image gets bigger, you have to keep searching across it. You have a lot of operations to carry out on each one, and then you may end up scaling the image and trying again at a different scale, and it can become quite intensive. In fact, that can be one of the reasons why you might, in many cases, keep away from this technique.
Great.
But it is widely used in certain industries.
Fantastic. So we've gone through all of these 5 families of algorithms. And Darragh, I want to thank you very much. Again, this is just a brief overview to help our audience understand that, there is a categorization that you can use in your head, even intuitively, to start going through the sets of algorithms to home in on, a particular set that you might use for one of your scenarios. So with that, we'd like to thank you very much for joining us, and see you all soon.